Okay, so we're taking a side trip away from the book. The next 3 days will just be notes worksheets instead of book homeworks. We're still working from basically a logarithm chapter, but it's more a homemade chapter. I like my own sheets better than I like the way the books did their book homework, so we're just killing the book a little bit. So we're back to the very exact thing we came in on 2 days ago, where we started talking about our goal was to be able to solve equations like these that had variables in the exponents. And those had a not real creative name. These are called exponential equations because they have exponents that are variables, so they call those exponential. I told you we couldn't solve all of these until I taught you about logarithms. Because again, going back to our 7th grade or whenever experiences you first hit equations, you always try to do the opposite. And whatever you do to one side, you do to the other. Those ideas are still in play, but for us to do the opposite of exponential stuff, we didn't know what logarithms even were. So we had to take a 2-day seminar on here's what logarithms even are, here's some things about how they work, and now we're back into where we came in. So out of these 3, some of them can be solved like that without logarithms because I was kind to you. Can anybody? First one is just 3. Because 2 times 2 times 2, 3 of those 2's makes 8. But that feels like what we've also done in the logarithm homework. You didn't know you were doing logarithms, but you were. There's been days in the homework where you're going like 5 times 5 times 5, and you're looking at your fingers, and then you're done, and like you got an answer. There's another one up here like that. The third one. This would be a 4. Because 2 times 2 times 2 times 2, 4 of those 2's make 16. You didn't know you were doing logarithms 2 days ago, but you were. Okay. Here, we knew 2 days ago we couldn't do this one. We decided that it was going to be somewhere between 3 and 4, and it's probably closer to the 3, because 10 was closer to 8, but it was going to be this never-ending, like pi, irrational, never end, never repeat kind of number, but we couldn't figure it out till today. So here we are today. Again, algebra has always taught us that we always do the opposite. So the opposite of exponential is logarithms. So I'm going to do a logarithm on the left, and that means I'm going to have to do a logarithm on the right. You are today going to need a calculator that can do logarithms. So if you don't have one of those, you can borrow one from me. We'll get you set up. But we need a calculator with a logarithm button. So here's an important thing to just understand. Log of 10 is a number. It's a weird number. It's not a number you know. It's not a number that's very simple. It's a number that's going to fill your whole screen. But the log of 10 is just, it's a number. So when you see this, that's just a number. But that's step 1. Do the logarithm on one side, so we do the logarithm on the other side. What did we learn yesterday about exponents in logarithm problems? When there's an exponent in a logarithm problem, it can just slide to the front. So that x exponent could slide in the front of log 2. And here we are with log 10. Again, this looks weird to you because you're not used to it, but it's just a number. What's this? That's just a number. Log of 10 is a number. Log of 2 is a number. So x is multiplying this weird number, but it's just a number, to equal that other weird number. So how would you solve that? If x is multiplying this to equal that, you'd have to divide. You would have to take the log of 10 and divide by log of 2. And now we need a calculator and to push some buttons. So if you don't have a calculator, let me go into calculator lending mode. You need one usually. Water goes down. Anybody else need one with a logarithm button?
I can just take Brian, is that cool? Or anyone from this class?
No, you can just use his.
I can take Brian.
Somebody else need a calculator with a log button?
Yeah.
You want one just for now? Just to play along?
Right there.
Anybody else need a calculator with a log button?
Paper towel wouldn't be bad.
Bloody, say hurt. Oh.
Boom. most calculators, when you push the log button, I think most newer calculators will set you up with a beginning parentheses.
Yeah.
So we need to do the 10, we need to then shut it down to limit the logarithm here to just the 10. Then hit your divide, do a logarithm button again, which starts you with parentheses, do your 2, close that off. If you're pushing the buttons right, this should get us 3.32, and I rounded it there because it does literally go forever. I'm just going to go to the hundreds place and round and call it a day. Is there anybody with any button problems in trying to get the 3.32 action going?
So, what do you have to do?
We're going logarithm 10. Probably need to close the 10 with a parentheses.
Yeah.
Then divide log 2, probably need to close the 2 off with parentheses.
So,
Yeah.
on this calculator, if you press like log, it just says error. You get the base.
Okay, then you're going to do everything on that calculator backwards. Go
So
10
parentheses,
first,
okay.
then log. Then divide by 2, hit log.
We got 0.301
Yeah, now hit it equals. Got it? That's
You
called,
said equal.
honest to goodness, it's called reverse Polish notation. And that's not a Polish joke, I don't think, but that's what that's called. That calculator, you have to enter everything backward. Most new calculators, you do the word, then the number. Some medium, the older, cheaper calculators, and I lent you one that's in that family apparently, you do number, then word. So that's a machine. If you wanted to do Hayden like the square root of 25, you'd have to do 25, then the root button, not root button, then 25.
I think I
Dollar store calculators are like that, everything's backward.
That's the.
Yeah, but it is what it
I
is.
did that one time and I was lost.
Question about first three. Could we have solved these doing it that longer logarithm way? Yeah, so if you don't want to think and you want to just do them all the same, just do logarithms every time. Here, we could have done the log, slide the x to the front, take log 8, divide by log 2. It would have given you 3, but if you don't have to do that. I don't do that. But if you want to do that, do that. So these two, is either of these an easy one or are these both hard ones?
Top one's easy.
Top one's easy. Top one you can just get 3. Because 5 times 5 times 5 is 125. If you can see those common, just do that. If you don't see that common, then take the path. Again, how did our path start in the previous one?
Log.
Log. We're going to do the log on the left, which means
Log on the right.
we have to do the log on the right. This side is basically done. The log of 100 is just a number. We can get it later from our calculator when the time comes. Be ready to wrap it up in parentheses for the calculator bowl. Then we need yesterday's lesson to be comprehended, that anything with an exponent in a log problem, you can
Move to the front.
move to the front.
Okay,
Yeah,
so
we,
put the little
yeah,
underscore in there, okay.
when we first started making those, we were doing that algebraically.
Okay, thank you very much.
So this one, how would we solve for the x?
You put the log in the 5.
No, 10 or 100.
You do the 100 on the
What
top
are
and the
you
5 log on the bottom.
What are these doing to each other?
The
What's mine?
multiply.
Multiply, so
So you
you're gonna
divide.
have to divide. So this divides by that. Push the buttons. I missed something the other day. I see a bad person. Something just happened to you. You gonna need revenge later?
Yeah.
You need me to help you, or you're gonna just take this upon yourself to get your revenge?
This on myself.
All right, that seems fine.
I broke this shoelace.
Push the button, somebody.
It's 2 points.
2.86.
It's a win. You might want to change seats. You might not want her behind you right now.
Hey, my star.
Be in a danger
How are you
zone.
doing today?
Something about that beginning report. So, a thought on solving this one?
Would you should be or something? No, it's
Same start as the other two.
Right in front.
well,
Log.
Log. And that lets you put the power
In the front.
in the front. So 2x plus 3 as a group, you'll need to do your own parentheses there. 2x plus 3, go to the front. log 6. And then this is log 216. That would be your first move. Do the log on both sides, power to the front. Question about that move? And what do you think?
Maxstone got 3.
3 will not be the final answer. There's going to be a 3 on our road, maybe.
3 kings, no. 3 times 2 is 6.
Thought on where to go
Plus
next?
3 is 9.
There's 2 reasonable suggestions. One that I'll shoot down, even though it's reasonable, and one that I
When I don't
accept.
say, you say.
We're trying to solve for x.
Rock, paper, scissors.
Yeah, I'll take that suggestion. This is just a number. It's weird, but it's a number. And that's just a number. So if you had 2x plus 3, a 7, and a 49,
You would divide the 7.
you'd have 2 choices. You could divide 7 into 49, or you could distribute. Either of those is valid. But since this is kind of a crazy, weird number,
Let me get it out.
if you distribute it, now you've got like more crazy, weird numbers. But if you divide and use your calculator, you're only going to have at most 1 crazy, weird number. So we're going to look to divide this by this, and that hits you with
3!
If you don't get a crazy weird number, that's a hint that at the beginning you could have taken a shortcut on this. And I'll go back and take the shortcut in a minute, but there's nothing wrong with where we are. Solve this now. Don't need the parentheses
Subtract
anymore.
the 3.
Subtract the 3, getting you
0.
0, then 0 for division, so 0 is the grand total. Question about that? We could have kind of done that at the beginning, but you'd have to recognize 216 is in the 6 family. So 6 was to a power here, 216 is 6 to the 3rd. So if 6 to this is equal to 6 to that, take away the 6's, and we could have just dropped in a little bit farther down the line. Okay, you don't have to do that, but if you see that coming, that's fine. But the first thing I would do before I start is just like 6, 6, 6, 6, 6. Am I going to land on 216? If I am, cut that corner. So here I would ask myself, 7, 7, 7, 7, 7. Will I ever land on 231? No. So don't go the shortcut. You've got to just do the math. Question about that idea? Okay, so what would this one look like
I don't know how
if we try to get to a situation like
I
this?
thought you late for your
Start
storm.
with the 3x minus 4 for every 7.
3x minus 4 would go in front of
Log 7.
log 7.
And equals log 2.
Equals log 231. I'd do one small addition to this. I'd get parentheses around that to keep that as a group. Anybody puzzled by how that's happening? A couple days ago, you wouldn't have believed you were doing a problem like that. That would have looked like Greek to you, and now we're like, oh, logarithm. Next move here, divide. So we divide, and what's going to show up on your screen is some sort of a ridiculous number that goes forever.
2.796 equal 944.
Right, so let that
2.8.
number continue to just show on your screen, and then your next opposite would be to
Or add.
add 4, and now you're like in the 6's or wherever you are,
Yeah, like 6.8.
okay? Then you still have to divide by 3, and you're back to hopefully in the 2's. Something like 2.27.
Yeah, 2.27.
That work?
Yeah, 2.27.
Something about that one. Then here's one oddball hard one. I think the homework has 1 or 2 of these. So this is like up a level from where those were. This one, first move continues to be
Log.
do logs.
Yeah.
So this would look like x
Log
log 6. This would look like
x minus 2
x minus 2
log 7.
log 7. This is different than all the other ones. Why is this different than all the other ones? There's 2 x's. So if you have two x's, ultimately, we're gonna need all of these x's to the same side, which means this time you don't have a choice. We avoided it before, but this time you're just stuck. You're gonna have to distribute. There's no way around it. We have x log 6. We can't get at this unless we distribute to get x log 7 minus 2 log 7. Don't let this freak you out. Again, it's just a number. We can get it from our calculator. Maybe not yet. We'll wait. We're not in a rush to get that figured out, but we can get that when we want it. Just leave it alone. How do you solve when you got a bunch of xy stuff?
Trick.
So that they're on the same side. So x log 6 can wait, minus x log 7 equals negative 2 log 7. We're closest as we've ever been to having a single x. We need to have a single x. We've done this a bunch of times before, just never with logarithms in the problem. How can we get from a couple x's to single x?
Take a GCF.
Take out a GCF, take out an x, and in parentheses is left with
Log 6
log 6 minus log 7 equals negative 2 log 7. To get the x alone, we're going to divide by this. And you're going to run into a thing that's called nested parentheses when you start pushing buttons. What do I mean by nested parentheses? Parentheses inside other parentheses. Because the 7 needs them for the button to work. This 6 needs them for the button to work. That 7 needs them for the button to work. You'll need parentheses around that when you divide. You're going to hit the parentheses buttons here a lot. But I would just punch this in one big mess, especially, maybe not yours, because yours that's backward, this gets real hard. But if you've got a regular calculator, just punch with what I say when I say it. Go negative 2, log, they start your parentheses, do 7, close them, then hit divide. Anybody not with me? Start a new set of parentheses. Log again. That starts you with these. Do 6, close it. Minus log, which starts you with parentheses. 7, close it again, because there's a double close here. You need to close the one from the 7, but you need to close the one that you started. Hit enter, and we're hoping that shows 25.25.
You know, there's 25 in there.
Question about that? Okay, let's talk one more thing that people never like to do, but your teachers always tell you to do this, and you never do it. Check. Okay, so if you want to check, take 6 to a power. Some calculators, the power may look like this, the power button. It's also possible your power button may look like that. I don't know what your power button looks like. But we want to go 6, power button, 25.25. And just observe what that is. Then go 7, power button, but 2 less, 23.25. Those two numbers should basically be the same. Why aren't they exactly the same? Because we rounded. This is not exactly the answer. That's a rounded answer. So when you check a rounded answer, they're like a little bit off maybe, but they should be about the same. 6 to a power of 25.25 should be roughly the same as 7 power 23.25. Did you find the power button?
No.
What a catch.
Left edge 4 from the bottom, it's this.
Ah, I'm
See
blind.
it? So it goes 6, it's called a caret key. So 6 caret key, 25.25. And then do 7 caret key, 23.25. They should be about the same.
Wait.
So you're gonna go 6,
Yeah.
power button, 25.25.
Yeah.
That's gonna be so big, it's gonna go scientific notation.
Yeah.
Then go 7, power key, and then it's 2 less, it was x minus 2, so go 23.25. And that should be roughly the same scientific notation that you had a second ago.
Yeah.
And then you're like, okay, I'm good. Okay? Anybody question, if they start you exponential, you work through logarithms? Question about that scheme? Okay, plan B, they start you with logarithms, then you work through exponential. Those are opposites. So this worksheet's going to do both of these things. If the problem has exponents, look in your math to do logarithms. If the paper has logarithms, look for your math to do exponents. We could have done these top two 2 days ago, and in fact, to some degree, we did. We couldn't have done these two until after yesterday, so that's why I held off on this. But here, just create an exponential problem. Who to the who is who.
Equals what?
Somebody's going to equal somebody. We go 5 as the base. Okay, since 5 is the base for the logarithm, 5 is the base for our exponent problem. Power of 3. The 3 already had its turn to be alone, so it doesn't get to anymore. The x that used to be in the mix, now that's an alone. The x is already alone, just push the buttons, 5 to the third, it's 125. Something about that. So bigger version, but same style.
4 to the third.
4 to the third.
8x minus 6.
Is 8x minus 6. To solve this, we first would need to acquire
The 4 times 4 times 4.
4 times 4 times 4.
64.
64 is 8x minus 6.
58. Well, or, sorry, 70.
70, add the 6, so 70 is 8x.
And then, like, 35 over 4.
Yeah, 70 over 8 is a decent move, but that does reduce. 35 over 4 is best. Or use your calculator, 8.75, it's all fine.
I usually say.
Question about this? Okay, we couldn't do this one until yesterday. Okay, why is this one harder? Why is this one worse than that?
Double logs.
There's 2 logs. So yesterday I was saying to you, there's always sort of a debate in math. Would you rather have 2 problems that are like little, or have one question that's
2 problems?
a little bigger? And the answer is, I don't know, depends on the problem. Here, if there's 2 logarithms, you can't solve them. You can only solve problems with 1 logarithm. So if there's 2 logarithms that are adding, you can exchange that using yesterday's lesson to have 1 logarithm if you're willing to. Adding yesterday connected to multiply. So if you have 2 logarithms that are adding, make a single logarithm, just multiply that stuff.
X squared plus 3x.
X squared plus 3x equals 1. Now this question is the same difficulty level as the other 2 we did. We just had to go from 2 logarithms to 1. If the 2 logarithms are adding, when you make 1 logarithm, you have to multiply those pieces. Question about that move? Then here's a trivia question from yesterday. We're missing a number.
The log is 10.
It's a 10. Anytime you don't have a base number for the logarithm, it is a 10.
So 10, 1,
To the 1, which is kind of silly to write that because it's just going to be
10.
10, but I'll leave that for a second.
Equals x squared plus 3x.
Agreed. And now we have like a few chapters ago kind of thing. With x squared, x's and numbers, you always make it equal 0.
X squared plus 3x minus 10.
And then you hope you can factor
X plus 5, x minus 2. Negative 5 and 2.
and then you hope that it factors. If it didn't factor,
Quadratic.
it's not going to happen on this worksheet. But it could happen in the world.
Let's get
Then here's another reason why you want to make sure you plug in the check, especially with logarithms. You can't do logarithms of negative numbers. So here, if you want to, go ahead on your calculator, punch log 2 plus log 5. Log 2 plus log 5 should basically be 1. And that's what we wanted it to be. If we check the 2, log 2 plus log 5 is 1, we're good. If you try to do log, just do log negative 5, hit enter, and what happened? error, math problem, calculator explosions. You can't do logarithms of negatives, so that's going to throw away 2 is the only answer. Question about that one? Small difference on the next one. What's the small difference on the next one?
There's more in the parentheses.
There's two
There's two
logs,
parentheses.
and then there's two, like, numbers in the parentheses.
Yeah, this had 2 logs, this had 2 logs. There's another fundamental difference.
Subtracting.
Subtracting. When it was adding the logs, we had to multiply. If it's subtracting logs, we're gonna have to divide. So I'm gonna make one logarithm problem with a divide. X minus 2 dividing
X plus 2.
x plus 4 equals -1. I'm gonna clear a little bit of space because I'm gonna need a little bit more than what I have. Then we want to write an exponential problem. 10 -1 equals that fraction. Because for the second one in a row, I didn't have a base, we just need to know there's a 10 there. It's invisible, but it's there. Now for 2 days in a row, I've been chirping at you about negative powers. Negative powers flip. So 10 to the -1 is 1/10. And now here's an old skill, way back to your Algebra 1 days. How have we solved things that are fractions equal fractions for a while? Cross multiply. So the x plus 4 multiplies the, which
Just
piece?
4 to the 1.
The 1. X minus 2 multiplies 10 to get
Minus 20.
10x minus 20. And then go at it. Let's get the x's all over here. 9. Get the numbers all over there.
16. Or, no.
24.
24.
Wow.
Fraction.
So,
Who over who?
24 over 9.
And then slight reduce.
8 over 3.
8 over 3. Question about that? One more tidbit, and this I think will be easier. Do we need to slide a little bit again?
Wow, what do you need?
Assistant
we're
cameraman.
taking this job.
The assistant cameraman's
You
taking
gotta
over.
undo this because it was tightened.
Here's a number you've probably never heard of before, is E. Okay. E is a number like pi. It doesn't end, it doesn't repeat. It's useful in certain problems that we'll do in the next day or two. Get into more of that in a little bit. E is 2.71828, 45, 90, 45, and then I don't know, but I know those first few. I know 2.71 because I need to. I know 828 because I used to live in Oakmont, and that's how the phone number started, and you double that up. And then 45, 90, 45 is easy for me to remember because there's geometry triangles, so 45s and 90s that we have tricks for and stuff, but E is like pi. It's a little bit of a more interesting pattern maybe, but it doesn't end, it doesn't repeat, but it doesn't matter either. On your calculator, you probably have an E button. It probably shares a key with LN. Next to your log button, you probably have an LN button. Anybody not see an LN button on your machine?
LN?
LN, probably right next to log.
Yeah.
Yeah. So what that stands for is natural log. I'm guessing this came from Europe where they talk backwards and they say more like logarithm naturel or something if you're in France, like they do their adjectives afterwards. But this is natural log. It's just a type of logarithm that deals with e's. So the whole homework, if you don't see e's, just use your regular logarithm button. If you see e's, just do the natural logarithm. Natural logarithm is set up for e's. So instead of writing log, I'm going to write ln and ln. And then here's a great fact. Since ln's and e's are opposites, they just cancel each other out. So if you do a logarithm with a natural logarithm on both sides here, all that's left standing on this is x. And the ln of 70 is just a number. Let your calculator find it. Punch ln 70. I'm hoping for 4.25.
Yep.
Plus.
So how would you start this one? ln. If you do that on the left, you do it on the right. Over here, who's left standing? 3x equals ln 94. Parentheses for this, your calculator can get you this number. To get the x completely alone, you just have to divide by 3. So ln 94, but cut your parentheses. Divide by 3, I'm hoping for 1.51.
Let me get back some.
Oh, not that. Something about that. Question.
I got it.
This one isn't ready for ln yet. A thought on this, why this is not ln ready quite yet? 6 is in the way. So your first move here is get the 6 out of the way. 14 divides 6.
7 over 3.
You can, if you want to reduce, no problem with that, or if you want to leave it, it's fine. We're going to need the calculator soon either way. Now what can we do to kill e's?
ln.
ln. ln kills e's, so x would be the ln of 7 over 3. There's some buttons. I'm hoping for a 0.85. Okay?
Yep.
Good. Anybody mad?
How do you fraction?
So our first move here, divide the 7. 7's in the way, so we're going to go e to the 11x, left alone. Divide 7 into 931, and that goes evenly, 133. Take that. Then ln eliminates e's to leave you 11x equals ln of 133.
Divide.
Then divide, x would be this, dividing 11, and I'm hoping for 3.19. From there,
Let me see this.
What is it?
3.19?
Let me see this.
No, 0.44.
Yes.
Yes.
I'm looking,
0.44.
right answer, wrong problem. The next one's gonna be the 3.19. I'm one too soon on that. So from there. All right, last one of the day. This one's different because the x is not in the exponent like it was in the other ones. The x is just sitting there. E to the 7th, for the millionth time I've led you to this kind of a statement today, e to the 7th is just a number. We can go get it on our calculator. If x is multiplying this number, to get x alone, you're just going to have to divide. So we're going to go 3497 divided by. To go e to a power, you're probably going to have to hit a colored button on the corner of most calculators. Like right here, there's a button that's some sort of color. Yellow, green, gray, blue, whatever it may be. It probably says either second or inverse or something like that.
Second round.
Somewhere on your ln key, you have an ln button, and then right above it, it probably says e to a power. And the color on the e to the power is probably the same color as this button.
Yeah, it is.
The buttons have like a dual identity nature. So if you want to use the regular ln button, you do. This, being the same color as that, for you to access it, you have to hit the colored key and then the ln key. So for this, we go 3497 divide by colored magic inverse second whatever it's labeled button, then the ln button, and on your screen it should show up e to a power. Give it its 7, hit enter, and that's hopefully the 3.19 that I was referencing.
Wait, what? So
So we're going 3497 divide by the colored button that says inverse or second or something like
Yeah.
that, the ln button, e will show up on the screen,
yeah.
then give it the 7, because it was e to the 7, and hit enter. Shoot you 3.19?
Yeah.
Yeah. Anybody, any kind of anythings from the wonderful world of logarithms?